Welcome to AI Frontiers, where we explore the cutting edge of robotics and artificial intelligence. Today, we're diving into groundbreaking research from August 4, 2025, uncovering how robots are evolving to collaborate with humans. From innovations in autonomy to advancements in sensing and human-robot interaction, this is robotics at its most transformative. In this presentation, we'll explore 17 groundbreaking papers that highlight the latest trends in robotics. Key themes include autonomous systems, advanced sensing technologies, and human-robot interaction. We'll also spotlight key findings and seminal papers shaping the future of the field, offering insights into what lies ahead for robotics research. Robotics is a multidisciplinary field combining computer science, mechanical engineering, electrical engineering, and cognitive science. Its significance lies in its potential to revolutionize sectors like healthcare, space exploration, and daily life. Researchers focus on creating machines capable of autonomy, adaptability, and seamless interaction with humans, paving the way for transformative applications. One dominant theme in robotics research is the development of autonomous systems. Examples include drones navigating orchards using vision-based systems, microplastics surveying robots operating on beaches, and AI-generated drone control systems created without human-written code. These innovations demonstrate machines' growing ability to operate independently in complex environments. Human-robot interaction is another critical area of research. Studies explore wearable devices for gait estimation, robotic manipulation for care tasks, and humanoid robots engaging in storytelling activities with children. These advancements aim to make robots safer and more effective collaborators in diverse settings, enhancing their ability to assist humans. Environmental adaptation is a key focus, with robots learning to adjust to their surroundings. Examples include hopping robots with tunable leg stiffness, terrain-adaptive gait estimation using wearable sensors, and advanced vision systems for dynamic environments. These innovations enable robots to operate effectively across varied terrains and conditions. Key findings across recent papers reveal breakthroughs shaping the future of robotics. Notable achievements include AI-generated drone control systems, proactive air purification with AeroSafe, and accurate gait phase estimation using wearable soft sensors. These discoveries push technical boundaries and open new possibilities for real-world applications. Methodological highlights from these studies include simulation to real-world testing for rapid iteration, deep learning for image processing and trajectory planning, and hybrid systems combining physics-based models with data-driven techniques. While these approaches offer significant advantages, they also present challenges such as computational demands and calibration requirements. A seminal paper by Peter Burke and colleagues explores whether AI can autonomously generate a complete command and control platform for drones. Using minimal high-level specifications, their AI model produced all necessary code for onboard and cloud-based components. The results matched or exceeded human-coded architectures, showcasing the potential for AI-driven robotics engineering. The AeroSafe project, led by M. Tanjeed Hassan Tanmoy, introduces a mobile air purification system that predicts aerosol concentration dynamics within a 35-second margin of error. Validated through extensive experimentation, this system outperforms traditional static air filters, offering dynamic solutions for managing airborne disease transmission in healthcare and public transportation. Zenon Zhu and colleagues developed a model-agnostic meta-learning framework for adaptive gait phase and terrain geometry estimation using fabric-based wearable soft sensors. Their system demonstrated superior accuracy across diverse terrains and subjects, requiring less calibration time than traditional methods. This breakthrough paves the way for unobtrusive health monitoring systems. Future directions in robotics include integrating advanced sensing modalities like hyperspectral imaging, refining reinforcement learning for real-world deployment, and emphasizing energy-efficient designs and adaptive materials. These innovations promise to enhance robots' capabilities and expand their applications across industries. This presentation was synthesized using tools like GPT-Qwen, Google TTS, and Grok, with content reviewed by human experts. While every effort has been made to ensure accuracy, oversights may exist. References for all cited papers are provided, allowing you to explore the research further. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archive.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive.org.